alcohols for AQA GCSE Chemistry. Okay, so some everyday alcohols you'll have met in a school lab in a spirit burner, perhaps. Alcohols are mixed with gasoline or as biofuels for cars. You'll know about perfumes. Well, the solvents for a perfume are alcohols. And you will know about wines and beers. Well, the alcohol in those drinks is specifically and only ethanol. So let's discuss the chemistry of these alcohols. So AQA covers the alcohol structures and names, the reactions of the alcohols, and of course fermentation. My idea is that as we go through, you participate by taking notes and completing tasks. So here are the first 4 members of the alcohol homologous series: methanol, ethanol, propanol, and butanol. And here are 4 molecular structures. Could you match the name to the structure? Stop the lesson, come back to check and correct. Okay, so what have we got? Well, methanol, of course, has got 1 carbon. So there's the match-up. Ethanol has got 2 carbons. Propanol has got 3, and butanol has got 4. Let's have a look at some different way of representing the structures. Could you match 3 names to those 3 structures? Stop the lesson, come back to check when you're ready. Okay, so I'm going to fill you in. Methanol, of course, CH3OH, ethanol, CH3CH2OH, and propanol, CH3CH2CH2OH. Okay, so butanol, can you write the correct structural formula for butanol? Stop, come back to check when you're done. Okay, so here is butanol, CH3, CH2, CH2, CH2OH. So that is butanol. Now, of course, all of the alcohols, as you will see, contain the hydroxyl group, the OH group. That is the functional group. So it appears in the structural formula and in the displayed diagram. Let's now look at some properties of these alcohols. Let's start with flammability. The first 4 alcohols readily combust. That is, they are highly flammable. So you may have done this in the lab, a watch glass with a small quantity of alcohol, a lit spill to the surface of the alcohol, immediate ignition, that is combustion. The evidence is flame. Now, importantly, that flame is a clean flame. There's very little smoke. You're also expected to produce a balanced chemical equation for the combustion. So methanol and oxygen, the 2 expected products, carbon dioxide and water for complete combustion. But unlike hydrocarbons, when we come to balancing for oxygen, there's already an oxygen in the formula of the alcohol. So if we go to the product side, we've got 2 oxygens and 2 more oxygens in 2 water molecules makes 4 oxygen atoms. Well, we've got 1 on the left-hand side already, so we need 3 oxygen atoms, in other words, 1.5 O2 molecules. So the difference between balancing a hydrocarbon combustion and an alcohol combustion is, don't forget the oxygen in the alcohol formula. So let's look at the combustion of ethanol. stop the lesson and balance that equation. Check it when you're ready. Okay, so 2 carbons, 2 carbon dioxides, 6 hydrogens, 3 waters. On the right hand side we have 2 times 2 oxygen and 3 makes 7 oxygen atoms. Well, there's already 1 on the left hand side in the ethanol formula, so we need 3 oxygen molecules, 3O2 to balance. Now, alcohols react with sodium in a similar way to sodium's reaction with water. So we would see some bubbling, we would see sodium floating. There's very little movement. The alcohol reaction is much slower. So sodium and an alcohol compared to sodium and water, the alcohol reaction is much slower. So sodium and let's say propanol, we would get sodium propoxide and hydrogen. Your observation, if you're asked for an observation, slower bubbling. Your observation would not be the reaction is slower. You need to give an observation if asked. The bubbling would be slower. That bubbling, of course, is hydrogen gas. So this is very similar to the reaction with water in that you get a salt and hydrogen. Let's look at the mixing of alcohols in water, for instance, in the alcoholic drinks that I mentioned on the first slide. This has got a technical term, not part of the specification, but if you're interested, miscibility. So we would say alcohols and water, or alcohols are miscible in water. So what it means is that water and alcohol, if we mix them together, they mix completely and do not separate. The resulting mixture has a pH of 7 at room temperature. In other words, a neutral pH. So a further property is the reaction of alcohols with oxidizing agents. The alcohols are oxidized to form carboxylic acids. So alcohols undergo oxidation to form carboxylic acids. The structure of carboxylic acids and their properties are for later on in your chemistry course. Now, what would be a suitable oxidizing agent? Well, there's more than one, but acidified potassium dichromate will do the job. You are expected to recall that acidified potassium dichromate is orange in color. Now, you may have done this in your classroom, in your laboratory. Collect some acidified dichromate, add drops of it to a sample of an alcohol, warm the mixture. The result is a green colored solution. The alcohol has been oxidized to the carboxylic acid. The orange dichromate has undergone a change from orange to green. You are expected to both know the change alcohol to carboxylic acid and orange acidified dichromate to green. Finally, the production of alcohols by the process fermentation. Anaerobic fermentation is a process that takes place in the absence of oxygen. So the first condition for the transformation of sugars, for instance glucose, into ethanol and carbon dioxide is that there is an absence of oxygen, that is, it is anaerobic. The second condition is, of course, that there is yeast present. Yeast contains active enzymes which bring about or speed the process of fermentation, and the temperature is controlled at around 35 Celsius, not higher, not too much lower. We set up a sidearm delivery tube so that any gases that are produced by the fermentation of the glucose or sugars bubble through lime water. Oxygen is prevented also from entering the conical flask by this setup. If we leave that for 3 days at 35 Celsius, you'll find that there's a fairly frothy mixture of bubbles on the top of the reaction mixture there, and there's been bubbling through the lime water. Those, of course, are bubbles of carbon dioxide, and of course lime water and bubbles of carbon dioxide turns milky white. In the conical flask, we're left with a mixture of aqueous ethanol and undissolved solids. Well, if we start with the mixture of aqueous ethanol and the undissolved solids from the previous slide, we're going to carry out filtration to separate the two. Obviously, we have filter paper within a filter funnel. A solution, the aqueous solution of ethanol, passes through. The undissolved solids collect in the filter paper. What is the general name given to solids that collect in a filter paper? And what is the general name given to a solution which passes through the filter paper? Stop and try and recall those names. Okay, I'm going to reveal. The solid trapped in the filter paper is called a residue. The aqueous ethanol that passes through is an example of a filtrate. You probably need to do some practice questions, so use your textbook and past papers. If you don't have past papers, then I recommend Physics and Maths Tutor website. Nothing to do with me, just got all the AQA past papers you could want. If you've enjoyed the lesson or found it helpful, please recommend to a friend. Please like, please subscribe. Thanks for clicking.